Okay, so a little bit of logistics. We need to have a reference group meeting with the class representatives about the course. So we do it in two ways. One way is that we have the issue tracker. You can submit comments and suggestions for the course in the issue tracker. So we have it open all the time. It is currently not really possible to do it anonymously. I don't think it matters that much, but formally we should allow you to do anonymous suggestions. And also we should have a discussion. So what we will do, we'll have a short discussion at the beginning of the class tomorrow with the whole class. And by asking a question, it doesn't mean you are the author of the question, is that the class thinks some things has to be updated or something, right? So you can delegate whoever asks the question, whoever is the bravest or whatever that is, right? So that maintains the anonymity because the messenger is not the author of the issue. But I do encourage you to use the issue tracker as well, because that is more ongoing thing, and we can address the problems of the course through the issue tracker. So like, having breaks and so on, it's not, just give us suggestions as you think about them. So that's one thing. The second thing is there were a couple of questions about the labs. The specs for the labs are set. So if someone wants to do half of the lab, they can try, and they can try to have it reviewed with the peers. If the peers say, well, we cannot tick you off because of whatever reasons, that's fine. So you can put on the sheet that it's like partially marked, okay? If you're marking someone who hasn't fulfilled all the requirements, and then we will look into it, right?
Possibly.
Yeah, if the lab is not marked, it's not marked. So we possibly will look into it. Good point. So better have it ticked. The labs are not super hard. The requirements are kind of, it's really hard to not fulfill them if you want to be ticked for the lab, right? But there might be some border cases that one of the points is not working for some reason and the rest are done. And then we can look into it. But I don't know. We will deal with it on per case basis. The best strategy is to just have the lab ticked off. The deadline for the lab being ticked off is March 18. And this is kind of a hard constraint because we want people to start working on the project around that time. So if we don't do that, then it will be like not enough time to finish the project. The last day of lectures this semester is 4th of May, which is Friday. And we technically should not have deadlines beyond that date. So I suggest we have a deadline for the project submissions to be that day, to be the Friday 4th of May. Which will be the day where the groups will sort of do a short presentation of their projects. So we will meet in the class and we will kind of run through the project. So the submission will be on the same day, let's say midnight, and then you can kind of, or we probably can be okay if we push the submission to like Sunday night. So you can incorporate some of the feedback from the presentations into the final, project, like small fixes or whatever that is. But the idea is to kind of close the projects at the end of the semester, at the very end of the semester. In the previous years, we were sometimes running late. We were pushing the submission deadline kind of beyond the classes because some groups wanted to do a little bit more after all the classes were finished. But with NTNU, it's kind of hard to do that, and we're more strict with the sort of a timeliness of the deadline. So I suggest, we stick to the final class, final Friday. Any opinions on that? Yeah, so when you will be scoping your projects, kind of make sure that you don't overscope it, that it's sort of reasonably tight, that you can manage it in the couple of weeks that we have for the projects. We will meet with all the groups initially to kind of review the scopes that you have. So then we will kind of catch potentially some of the projects that are over scoped, but yeah, I'm just kind of giving you the gist of it. So when we have the projects announced, you will have to form a group and you will have to draft a little bit of a spec of what, sort of like we did for the labs. What's the main idea and what is the sort of a success criteria that you want, some features that you want to have. And then we will kind of go around and we do that. You usually do it with the stakeholder. We will have some projects which are with the external stakeholder. We'll have some internal projects. And you can propose your own project as well if you want, in which case you will be working as sort of a product owner for your own project. So one of you will become this sort of a product owner. What's the preference, whether to do something with outside companies or people or whether with internal? It's flexible. From the previous years, most projects were done for external stakeholders, because then you have kind of a spec given. They tell you what they need. And most of the time, it's quite simple what is that they need. If you want to work on something of your own interest, then that's fine too. We did have that with some of the game groups doing a game. So yeah, it's open. Anything else? So tomorrow's lecture will be on internationalization, and today we will talk a little bit about Firebase. So I talked a little bit about Firebase on last Friday lecture, but just as a summary, I can yeah, give you the so Firebase is composed of a number of modules or products. And some of them we discussed on Friday, but I will but it's sort of it's listed here, right? So they support Gmail, Google Authentication, Facebook, Twitter, GitHub, email password, and the phone-based. So a user can use just a phone number, and they have the workflow to ask the user for a PIN and so on. So you can use all of them or one of them. And this one is sort of the traditional email password one, right? So that's one aspect of Firebase, authentication. As you see, it's kind of buried in a number of different things that they offer, but this one is quite important, and we will deal with that one. The other one is you often need to store something on the backend. So you need to store some data, high score of the user, or calendar entry, or whatever your app is doing. So then the user doesn't store it only locally on the phone, but you store it on the backend, and then it can be either shared among other users, or the same user, when migrating to a different phone, can kind of get it. There are mechanisms to do that. You can use Android services to do the backups and restore from Google services. But for example, if the user initiates something on the mobile app, and then you have a web app which wants to fetch the same data for the user. So you may allow users to log in to check their profile on the website, and they have a mobile app for tracking, like their runs or something. Then you need to have this backend. You need to have the sort of a database which stores stuff. So this is what Firebase was originally for. And the idea was that you have a backend database which spreads the change to registered listeners in real time. So it is sort of a database which notifies about the change in real time. Why we would do that? Well, let's imagine you want to make a chat application, and a user has a chat client, and the user types in a new message. That message goes into a database as a new message from this user, and is immediately spread all over the other users to see that you've typed something. So, you know, like Facebook Messenger or Twitter or something like this. You can easily do that if you have a backend which allows announcing the change to anybody who is interested in that change, and also anybody who is allowed to see that change. So you have kind of a permission system, which allows some data entries to be public, or some data entries to be visible to a group, or some data entries to be only visible to the user, right? So if somebody sends you a private message, only your devices which are authenticated with Firebase will get the notification. So that's what this real-time database was originally. So I am planning to use this module and this module because those two together allow you to have a variety of different applications, including chat, including to-do lists, including kind of calendar sharing, including activity trackers, runs trackers, what have you. So they cover a number of things that could be useful. So we focus on authentication and real-time database. This year, Firebase announced Cloud Firestore, which is another backend for the database. So I will briefly describe the difference. This one is like a giant JSON document which stores everything in a single JSON document. Okay, so you have a root, and then you can put as many properties as you want, and you will organize your data in this kind of a giant JSON structure, right? So imagine we have imagine you have an application which you want to do for chat. How would you do that? How would you organize yourself? So this is your root node, and then you can do whatever you want, and you want to do a chat application. So you want to have, you need users, right? So you will need kind of a concept of the user, and you will need a concept of a message. Let's say we only have public messages. So as a user, you can register, and you can say, well, I'm Bob. And then in the chat, when you, so kind of Bob says, yay, okay? And then Simon says, hi. And then you may have a date, right? So I can have kind of when it happened. So it happened on today at 21:34, right? And this 21:55. And you may have a date here. So we have users, we have a message, and it all goes to a public forum, right? So how would you organize that? Well, you have to say, well, I kind of need users, right? So you will have one property of this JSON, which is a user, and this would be what? It could be an embedded JSON, or it could be an array. So let's say we use an array, right? So we will have an array, and then you will have some sort of JSON documents here, which have, let's say, a property name, and then you will have Bob, and then you may have some ID to link you back to your authentication backend of who Bob is, right? So Bob appears here as Bob, but here you have it linked. So this will be some sort of a long identifier which links you back to the user, right? So we have Bob, and then for Simon we have the same. So we have name, Simon, and then we have his ID, which links us back, right? So we have this, and then you have to say, okay, so we have one property which is a user, and then I need another property which is to do with the messages. So how you gonna represent the messages? Well, you need to have another property. Let's say you have messages, okay? And then again, we probably will use an array, right? So you'll have an array, and then you will have again some sort of a document structure which will have properties such as, so we have to say who sent the message, when, and the body of the message, right? So if we have this as an array, we would kind of lack an ID which points to the first entry of the array, right? It wouldn't really work that well because I have an array, so I mean, if Bob sent a message, I cannot link him to here. I have to link him through the ID, and then to find out, because in the ID, let's say I have an email and the password. I don't have the nickname, the Bob thing, right? We could push the user details about the messaging system into the authentication backend, but then we are mixing two domains. We're mixing the authentication with the logic of what we do. So in the logic of what we do, we need a nickname, but for authentication, you don't need a nickname. Then it's a little bit ugly to mix it. So it's nicer if we separate it, right? So if we separate it, using an array here doesn't really work because we cannot say, well, who? It's you know, the 0th entry from our array, right? It's very risky to do that because if we push something in front, everything shifts. We cannot do that. And then, you know, so we have some problems here. Like, okay, we have to think, then we cannot really use an array. We have to use something else. We probably need to use an embedded document which will have some sort of ID as the key and this as a value, right? Then we can refer here to this ID. And that's how Firebase works. So I will show you to kind of demonstrate a little bit the point. Let's do a little bit of hacking around. I may need a slightly different browser. Come on. Let's do this. Yeah. So if I go Firebase here, I go to the console. Yeah, actually, let's go to this one. I will have my old one. Right, so here you see, this is not a chat, it's I'm storing, I have users, and the users can submit a paper, can submit an article. So I have a concept of users in my JSON structure, and the concept of articles which are linked to courses, okay? So if we unfold this, we see actually users is a big document which has key value pairs, and the key is kind of the ID, which I can reference to, and the value is email and name, right? So I have a key and I have email and name, right? As you see, I don't actually have an ID here because I link this user to my authentication backend by email. It's the same kind of a unique key, right? So sorry for Joel. Well, imagine that yeah, this one is good. So I have some sort of an email and some sort of a name, and it's wrapped inside a kind of a document which is indexed by the key which I have on the left-hand side. So I have a document with the keys and values, right? It looks kind of ugly, right? And then with articles, it's the same. I have keys, and then the article is author, published, tags, title, whatever properties you have. So I have kind of a two-level structure. I have my collections and the top level. So those are my collections, which I can search. And then inside, I have keys, which identify me some documents, right? You get the idea how that works? And it works, right? It is fine, but it's a little bit tricky. So then when you're searching this, you have to set the root of where you start your search. So for example, if you want to search articles by author, you have to say, get me all the subtree from here, from this point, right? Because if you get the whole thing, then that's not what you can search by name of the author of the article, right? So you have to say, I want the Firebase to give me a root from where I can run my query, and you will say, give me the root which is here, anchored here, and it will give you the kind of the pointer of that document here at this location. So instead of giving you the root, it will give you here. And if you see from here, I have key value pairs, and the keys are the IDs and the values are the documents. So then you can say, okay, disregard the keys, in the values, find me all the documents which have author being particular author. And it can kind of trim the document to you and give you the sub-documents which are fit your criteria. And then you can sort of find out what ID that was and find all the other properties for that document. But querying and kind of organizing your data following this kind of pattern is a little bit, well, it's not that natural, right? We think about JSON documents as documents. It's a single document which we pass around. We don't usually think about the JSON document as a collection of documents which we search this way as the Firebase organizes us. So for a few years, that was the model, and you have to work this way. So every time you're planning your app, you have to think, okay, how do I organize my collections? And then your collections typically become top-level properties of your document. And then how I organize my documents in the collection. And then those typically become this sort of a structure inside your collection. But it's much easier to think about it as I just described, as collections and documents inside the collections, right? So how many of you know MongoDB? How many of you had XML databases? Do you have a database course now, or did you have it last semester?
We had it last semester, but we didn't really use XML for databases.
Okay.
We did do some XPath and traversing XML, but not really.
Okay. But you kind of get the idea of like structuring the documents and the collections of documents, right? You will not kind of spend a lot of time talking about MongoDB, but MongoDB is sort of a non-SQL database. So how many of you know SQL databases? All of you, right? Yeah. So SQL databases organize data in terms of tables and rows. So each kind of document is a row in a table. The table has some properties, and then your table can be users, and I can have a property, email, and nickname. And then those are my two columns, and then each row will be one user, right? In here you see that we don't have a concept of the column and a table. We have a concept of a collection and documents, but it's sort of similar. I have some properties, and then those properties are kind of like columns, and then all of that, this is sort of like a row, but it's actually a document. The difference is that SQL forces you for all the documents that you have, for all the rows, to fulfill the columns. Here, I can have an arbitrary properties for my document, and each document may have something that is different from the other document. So it allows kind of a bigger flexibility, right? So I can, again, I can demonstrate that. If I go, oops, let's say, I go here, I made it bigger, I say, okay, I need to run Mongo daemon, Mongodb. So I'm running my local database on my laptop, and then if I go here, I can connect. So it's sort of like the same like with MySQL. You can connect to the backend using kind of a command line shell, right? So I'm connected now to my local Mongo instance on the database, and I can show the databases that I have. So I have an admin database, I have EduLab, I have IMT3671, and so on. So let's say I go to use students DB, and then I can show collections that I have, and I have only one collection which is called students. So then I can say, okay, from DB students, which is my collection, find me one document with the a first one, a random one. I put no criteria for search, and it says there is nothing. So the collection is empty. So let's use a different database. Use EduLab. So let's use a different database. Show collections. So let's make it bigger. So here I have a person database. I have a review. I have a comment. I have an article, and so on. So let's say find me. So DB article. Find me one random article. And it says, okay, your article is the best book ever, written by me, published last year. Wow, awesome. And I have those properties, right? What I can do is I can record that entry as a variable. And now O is the document that I just found, right? And I can say, I can set a property, is this book published, to true. So I've just added dynamically an extra property into the document. And then if I say, oh, it has this extra property, right? And if I would say db article save, oh, it would upsert that document doing that modification. It would add this extra property to my document. And it's dynamic, it can do that, right? It's the same here with the JSON. I can add an extra property and there is nothing stopping me doing that. And then when I found a document, I can see, does this document has this property? And some will, some won't, right? And then I can do something. So compared to SQL, NoSQL allows you this flexibility and playing around with what properties do you really need before you actually deploy your system. So with SQL, you have to plan your structure of the tables, and then you stack with it. Here, you can sort of do it more dynamically. So that's one argument. The other argument is with the updates and with the searches and with the read-only access. Modern SQL databases are optimized for this type of access as well. Historically, they were optimized for locking the, like if I need to update something in my database, it was really hard not to lock the whole table. And then sort of a read-only access and read-writes were a little bit suboptimal. That's why NoSQL kind of provides more flexibility in terms of how data is accessed and how data is modified. Modern SQL databases do that as well. So some of the advantages of the access and read-write access are sort of blurred now. It depends exactly what you're doing. One notion where non-SQL databases are still a little bit better is when you have a situation where you can deal with inconsistency. So let's imagine that I have some sharding going on and I have my SQL table kind of being distributed. So different nodes are kind of writing and reading from it. Typically, you will use something called transactions to make sure that the kind of changes to your database are kind of atomic and they don't create a situation where your table is kind of in an inconsistent state. So if I have to modify two rows, either like, let's say you're sending money from one account to the other, right? So you have to subtract money from one user and put it into the other, but you cannot subtract without adding and you cannot add without subtracting. You have to do the change kind of atomically, right? So SQL databases are better because they will allow you to have an atomic transaction which will either do those two things and succeed, or where they will try to do and one will do one or the other and then it will fail. So it will roll back to the original state. With non-SQL databases, we don't have a concept of transactions. There is no such thing as a transaction. The transaction is basically a modification of a document. I can atomically change this document by modifying different properties, but I cannot atomically modify two documents, right? So with NoSQL databases, there is kind of a little bit of a performance benefit of lifting off the atomicity of some of the operations. So in situations like chat, for example, where we actually don't care if we lack the atomic transactions, we may choose NoSQL database because we will have a little bit of an advantage of lifting some of the constraints. In any case, Firebase supports this type of structure, but it's a little bit awkward. It treats everything as a single JSON document. In Mongo, I have the concept of collections. So I have I can organize my model, my data model, into collections, and each collection is a sequence of documents which have some properties, and they have a concept of ID. So each document that I store in the database has some sort of a unique identifier that I can reference and link, right? So I can find out, for example, who submitted that book entry by linking users and articles in another collection by linking the kind of IDs. And here I can kind of do the same, but it's very awkward because if I have a link in here to what user's ID was, or in which courses my article was used, it's a little bit more cumbersome. So even though that system works very well, what the team did, they said, this works, it's fine. It allows to do the real-time updates and so on and so forth. But most of the time, what you end up doing is you end up fetching kind of a subtree of a giant JSON document, right? So if I need to search, I need to sort of my expressiveness of the queries are kind of limited to parsing and traversing this sort of a hierarchical tree. So it's much easier if I can do queries using some sort of a query language like we do here. So for example, if I were to find, okay, let's try to find all the books, all the articles that start with the okay? So I can say db article, find me all the documents which have a particular query, and I have kind of a query language here. So I can say the title, title has a regex pattern that where is the here, that starts with the, right? So I'm searching by title, and with the regex expression that says every title that starts with the, give it to me, and I can see, and I can count it, so I can see how many of those I got, and you see I got 2, right? So I can kind of run a query and say, give me this, and the database will return me 2 documents. If I were to run this similar query here, I cannot really do that. I can only say, okay, Firebase, give me the subtree of the whole database that I have from this point, and then I have to loop through and find all the documents that I need. I need to filter it kind of on the client side, right? Like the expressiveness of the query language here is basically give me a subtree of the JSON, right? I can say, give me a subtree of the JSON, which is the glowing fire articles and that key, and in which case I will only get 1 document, right? It's fine. I can do that. I can fetch just 1 document, but I cannot fetch a subset of documents. So the queries are kind of limited. So what they've done, they said, well, it's great. This one is kind of working and it's fine, but they wanted to have something that is similar to Mongo, which allows you to have collections and a more expressive query language. So they have a different backend, which is currently in beta, which is called Cloud Firestore, which is basically a non-SQL database, which allows you to have a concept of collections and documents, which is sort of the next generation of the Firebase storage. So you can watch the video. You can kind of check how the querying works. And then there is, let's say, compare Cloud Firebase with real-time database. So they have this comparison, which choice is better for you, right? So real-time database, the usual classical one, stores data as one large JSON tree. Cloud Firestore stores data in documents organized in collections. So this is more like Mongo. This is more like one giant JSON tree. Simple data is very easy to store, of course. If you just have one collection, then it would end up being just one sort of a JSON tree, right? Simple data is easy to store in documents, which are very similar to JSON. It is JSON effectively as well. Complex hierarchical data is harder to organize at scale. As you've seen here, no, you've seen it here. It gets a little bit tricky. Like if I were now to modify one of my articles, how do I do that? Like, how do I find which one I need to modify? I need to change, a year of one of the articles. It gets unwindly. And it's sort of, I don't really have any way of, filtering this stuff. So for example, for courses, I try to be a little bit more organized. So I sort of organized by course tag and by year in which we ran the course. And then I had the name which is attached to here. So I sort of see some things, but yeah, it gets kind of complicated how to organize your database. So that's why they sort of say complex hierarchical data is harder. Complex hierarchical data is easier to organize at scale using sub collections within documents and kind of a query language. And then the query as well. It's sort of querying here is much harder than querying here. This is easier. They have both are very similar in terms of support. You can only sort or filter on a property, not sort and filter on a property in a single query. Here you have the full query language, right? Queries are deep by default. They always return the entire subtree, right? That's what I was saying. It's a little bit tricky to run your queries in such a way that they return sort of filtered. You can filter after you've done the queries, but the query will return you the whole, as I said. if you have a query on articles, it will return you from that point a subtree, and then you can filter it. But you cannot get individual documents from the kind of query. Whereas with this one, you can you have, first of all, you have indexes. This doesn't support indexes, so that doesn't scale too well. And you can kind of chain filters and combine filtering and sorting on, in an arbitrary way. You can write a shallow queries for sub-collections. You can get a sub-collection of your collection, so it's much more flexible. So all in all, if I were to choose, I would probably choose this, but it's in beta, and we don't know exactly how it will work, right? So for those of you who want to experiment with Mongo-like database, you can use this, but you sort of a little bit on your own. Like there is a little bit less tutorials and there is a little bit less how-to. For those of you who are not adventurous, I recommend just using the old way. The old way is very solid. It always works. There is a ton of tutorials, and there is a kind of an easy way of finding your information about how to do things. There is a lot of, Stack Overflow questions and answers. With this one, well, you are a little bit on the uncharted territory. That really was announced like 2 months ago. So there is not much documentation. I mean, there is documentation on the Firebase, of course, but you will have to read the docs. Here you can probably go by reading Stack Overflow answers, right? Here I don't expect a lot of Stack Overflow questions and answers yet. The other thing is, because it's in beta, it's very likely that some of the things will get tweaked before it goes into production. So some things might be a little bit experimental, whereas things here are kind of rock solid. They've been using the same API for a number of years, and it's sort of the same. The disadvantage of this one, apart from technology, is that I suspect Google will phase it out in favor of this one once this goes into production, right? So the lifespan of this technology is limited because it's a little bit restricting. And also it's a little bit harder for them to charge per use in this one. It's a little bit easier here. So they, over time, they will migrate to Firestore. So if you're sort of reviewing which of the backends you should use, you have those two choices. You have the real-time database and cloud Firestore. They do differ. They provide the same functionality of you being able to store data on the backend, but they have slightly different properties, and this one is in beta, right? Which one you should use, I don't know. I would use this, but as I'm saying, it carries a little bit of a risk of working with not fully tested and fully supported product. But we're not developing a commercial application. Like if we were developing commercial application today, I would probably pick that. But because we're learning of how to do this kind of a cloud-based storage, I would probably pick that. Okay, so let's have a break, and we will continue with some examples of how we set things up with one of those and how the authentication works.
One question.
Okay.
But the email said I fixed that. Now I can retrieve data from the database.
Yeah.
Which is nice. But
All right, so let's continue with the Firebase discussion. I will talk a little bit about authentication. How many of you done authentication before for something that you needed authentication? Yeah. So those people who did that, you've used like a email password combination? Yep. Or something else? Tokens? Okay. So you've integrated yourself with some auth provider. Yeah, and then you got token, and then you've used the token for your API. Yeah, okay. So as I was saying, rolling out your own authentication is a lot of work, and you will never do it as good as the existing auth providers. And also for the user, asking the user to register again with something, it's a bit cumbersome. So when you're doing an Android app or iOS app, usually you piggyback on an existing user auth. And the advantage for the user is also that if I am using an app which asks me to use my Gmail login, which I have to use on Android anyway, it's very seamless. I just say, yep, and it's kind of seamless to do it. I don't need to type anything and so on. I don't need to remember a new password. And I can go always to my Google console and disable the app access, right? So even if I created an account and granted an access, I can always go and revoke the access. I'm kind of in control as a user. So it's a good way of setting things up. So with authentication, as we indicated earlier, you have a number of options that you can use. So you can use the Gmail and all those other providers as the authentication provider. It is good for testing purposes to have an email password authentication enabled as well, because you can quickly create new users for testing purposes and sort of authenticate them using your password and test the access and test the app for yourself. So even though you're opening up the flow for the users for the production to use one of those providers or multiple of those providers, I recommend you start with the normal email password authentication, because that kind of gives you the ability to create users and test them easily. So what do you need to do? You need to sort of think about the flow, like how the application will sort of register new users and how the application will validate the users have been already registered and how the application will authenticate access to some resources. So you have to think, okay, when the user needs to authenticate, at the beginning of the app or when the user actually needs to do something. The second thing is you have to pick the providers that we will use. So which of those providers will you use for your app? So let's go to this app. I sort of started doing a project for the chat using the Firebase. Let me just make it bigger. And if you go to the authentication, let's go back one step. So if you go to Firebase, if you go to Firebase console, you have this kind of a big plus button which says, okay, you can add a new project. So when you click it, it kind of asks you, okay, what's your project ID and where you will be sort of mostly working. So you can say Norway here, and you can type your project name. And then when you click create project, you will be sort of, you have the project instance kind of created for yourself. The project has a name, and also it has this unique name with some kind of salt added at the end. This is a typical pattern for projects that may have conflicting duplicated names. And because Google is using those to generate kind of URLs for your API calls, you cannot have a conflict. So you cannot have an API URL which conflicts with somebody else's chat demo, right? So if I go back one step, if I like, how likely is it that someone else will create a chat demo app? Very likely. Like the names, the human readable names are sort of, people are coming up with the same names over and over. So there is this additional bit which will be part of your URLs and some kind of identifiers, which is unique. But this additional bit you can edit. So when you're setting up your project, you can sort of go to settings and change. Google gives you kind of a random one, and I tend to kind of fix it to something that I can easily type. So, I have D8, D8D, and this one I have CD, CDA, right? I just did it manually. Like, so after you created a project, you can go to settings and change the completely random one to something that is still random but has some regularity to it, right? I just do it just for the sake of being able to type the URLs manually by hand. So then when you go to the project, you have this sort of a project console. And we're sort of concerned about the first two. So the first one is the authentication, and the second is like which database you will use. I've already picked that I'm using Cloud Firestore. You can change. You can pick either the real-time database or Cloud Firestore. I've picked the Cloud Firestore, so I have collections, and I have documents. So as you see, I have users and I have messages. And my messages collection has one document, which is this, and my users collection has one document, which is this. So I just started. And you can add manually documents here, and you can modify the existing documents, and you can add collections. So you have the add collection button, which will add a new collection. You can add document, which will create a new document. And this is the key of the document. And then with authentication, you basically have a database of all your users in the app. And I don't have any at the moment. So you have to go to sign-in methods and enable the ones that you want to use. So I have enabled email password, and I have enabled Google-based auth authentication. There is one more which is called anonymous, which is kind of fun to work with. What's anonymous login? Well, it is sort of an ability for a user to create an account in your system without typing anything. It's kind of a very seamless way of integrating your flows with users which you sort of have, but it's still anonymous. So what's the difference? Let's say you have what is the difference between I have my backend. So I have to move the camera. So you have the world with the users, and then you have your app, and then you have some sort of REST API which your app is using, and this REST API does something to the backend. So here is your backend, and now the user interacts with the app, and the app interacts with the REST API, and then you do something with the backend, right? So you could say, I actually don't care about the users, like the chat example, right? I really don't need to track who is who. I just need to have a nickname, and if you have this nickname, you can sort of post messages, right? Let's say I came up with a nickname Bob, right? How many different people came up with the nickname Bob? Possibly many, right? So then you can use something like Discord where you add this random kind of hash at the end, right? So I can add something here, and then I'm kind of unique. So even if somebody else picks the nickname Bob, the Bob with my unique salt at the end is different to the Bob with the other unique salt, right? But then you would have to force this generation automatically, right? So you could say, okay, I have a mechanism for a user. When the user kind of logs into my app, there will be some sort of, the user can pick the nickname, but the nickname is unique to the user, but I add this sort of very unique bit to the nickname. So when the user submits the messages, I remember that. You can store it only on the phone. I don't need kind of to authenticate that Bob, whatever, is the real Bob. So one problem with that is that if somebody wants to pretend to be me, Bob4549, they can sort of try to fake the call into my backend, right? If they go through the app, they have no control over that part. They can say, I want to be a Bob, but every time in the app they say, I want to be Bob, they get a new unique one. So they cannot pretend to be me because only my instance of the app already generated that, and I can send messages as me, but somebody else with a different app cannot fake this. But if they go directly to the API call, they can do whatever they want, right? So even though this is quite safe mechanism for uniquely identifying users in the chat app through the app, I cannot block somebody directly going to the REST API. I could say going to the API is only limited to my app, right? My app authenticates, and only my app can talk to the backend, which is one mechanism for solving that. So I will have kind of a user which is embedded into the app, and that user authenticates with the backend. But what's the problem with that? It has to be embedded into the app, into the binary of the app, right? So you can disassemble it and then extract the credentials and do basically that, right? You can interact with my backend again from a script, right? So there is no really easy way of completely disallowing people to mess up with my system through going directly through the REST API. So you say, okay, in that case, I do need to have some sort of authentication, but I don't want to make the user sort of cumbersome for the user to do this authentication. I want something that is very lightweight, right? So this anonymous authentication is basically the solution to this problem. It says talking directly to the backend via the REST API is not allowed unless you authenticate it, okay? But to be authenticated, all you need to do is you have to have the app kind of create the authentication workflow for you, but you don't need to register, you don't need to do anything yourself as a user. So the user kind of goes here and it says, okay, I want to use the anonymous. So if the user goes into the app and doesn't log in, they cannot interact with their backend. If they log in with the anonymous login, they have some sort of a cookie, some sort of a track being associated with them, and they can log in using this anonymous login. And in the Firebase, when you do that, in this user database, you will kind of get an anonymous user created. Okay, I can show you. I have an app which we are using with Firebase. So let me open another tab. So I have another app which already has a bunch of users. So in the sign-in methods, we said email password is fine, Google authentication is fine, and anonymous users are fine as well. So, and I can also show you how the flow looks like. So we have, it's not a mobile app, it's sort of a web app. We have a button which says you can log in or register with the app, or you can log in anonymously. If you are not logged in, so if I go, I think it's called escape. So if I go to a particular event, if I'm not logged in, I can see questions people asked, but I cannot vote. So I cannot vote on questions, and I cannot add new questions. So I can only view, and that's it, and sort. I cannot do anything with the questions. But if I log in anonymously, then so there is a bit of a catch here. So if I log in anonymously, then I have an account created for me, which is the anonymous login, and that account is kind of linked to my session, and I cannot really log out. I'm always the same anonymous user. The app doesn't know who I am, but they know it's the same user, right? So if I click here and I've already have an account, then I kind of get stuck because I cannot log out and use my previous account. If I don't have an account, and if I log in using the anonymous login, then I can always upgrade that account to a known account by logging in again with the particular credentials. So it's a little bit tricky for me to demonstrate that because I already using both. I can do that with Firefox, I think. So I have a third browser on which I don't have the credentials. So if I go, okay, so now again, if we go to this particular event, date. What was the key? Panel, yeah, sorry. Thanks. So as I said, I cannot vote on questions and I cannot ask new questions. But if I log in anonymously, I'm kind of an anonymous user now, and suddenly I can ask questions. So I can ask questions and I can vote on questions. So I can mark that. Best app, it's now 15, right? So I can interact with the app and I can modify the database, but I am kind of an anonymous user. And then as anonymous user, I cannot really log out. I prevented users to log out because then they would be creating multiple anonymous accounts. So from the UI, you cannot really log out from your anonymous account as you are, but you can log in with one of the other flows, or you can log in with the email password, and then your account is upgraded, right? So if you check the console, you will see that we have now a bunch of users, and some of them are anonymous, and some of them have registered, and some of them use the registration and Google, right? I've registered and used the Google one. So if this anonymous user, if let's say I sort it, so I just accessed it right now, right? So I am probably this anonymous user right now with that session that I've created. So I can upgrade myself by logging in with Gmail to G, but you cannot link a Google account with anonymous account. You can only upgrade. So, but as you've seen, it sort of allows a user without doing anything to kind of have the functionality. And what it allows is that I prevent people to misusing the API. Like, it is now a little bit harder for someone to write a script to kind of mess up with my backend without authentication at all. So they will have to authenticate. They will have to create this anonymous user, register, and then do the API in the script. And then what Firebase does is that where we are, if we go to the Firebase console, you will see that if I pick anonymous that I want to enable it, I can save it, and there is quota which says to prevent the abuse, the email password and anonymous signups are limited to some amount per hour from the same IP address. So because you could generate new email password pairs in a script as well and kind of abuse the backend. So the Google has sort of a quota. So current quota per hour is 100. So I will not have more than 100 users being kind of generated and spamming my system. And I can change that. I can change that to whatever your average new user kind of come. Like 100 is very optimistic that I have 100 new users per hour. I don't expect that. I kind of expect 0. So I can change the quota to be really small. But then let's say you have some sort of event and you have people kind of registering, then you may change the quota to you will say tomorrow between 4 o'clock and midnight, I will have a conference and a lot of new people will be using the system, so I can change the quota to be different. I can change the quota to 1,000 and, change how long it's gonna last, the new quota. So you can set some sort of mechanisms for preventing the abuse. So anyway, you kind of enable some of the things that you need. I do encourage you to enable email password, one of the social ones, and maybe anonymous one as well. But as I said, with anonymous one, it's a little bit tricky because if you do the flow correctly, you should disable an ability for an anonymous user to log out, because then you lose the sort of the tracking cookies or tracking tokens. They will be just new user, right? So you can, for testing purposes, have it enabled, so you can kind of create a user and do something, log out, create a new user, and see as a new user what you can do with the old user content. So for testing, I've done that, but for the production, as I showed you, I don't have not in here. I showed you in Firefox, so I don't have a logout facility here. Can you log out as an anonymous user using the API? Yes, you can technically. You would need to extract the kind of the cookie and make an API request to the backend or to the Firebase, which would then log you out. But it would be a little bit, I mean, it's technically possible. It's a little bit difficult for an average user to do that. But for an average user to click here and log out and log in again as an anonymous, it's super trivial, right? So if they want to upvote something multiple times, they could just log in anonymously, upvote it, log out, log in, upvote, log out, right? Now they cannot really do that. Okay, so let's close that. Let's close that. And let's go back to our chat demo. Let's say we enable those three things. Then we have to say from where the users can issue the queries. So for your local tests, of course, you will be doing your local tests from localhost. So having a localhost enabled is kind of good, because it allows you from your local laptop with localhost to talk to the Firebase and have some things done. Then you will have things which are, as I said, this URL has this kind of a unique extra. So I have chat demo with this .firebaseapp.com. So that's the backend for the database and for everything Firebase is doing for you. And this needs to have access to the authentication mechanisms because it needs to validate and do things with the tokens. So you have to have that as well. So then you have two other properties. You can have multiple accounts per email. By default, you are allowed to have only one email per account. So if someone has an email address in your database, it will not be possible to have a user, two users with the same email address, right? So you're sort of assuming that if there is a person, you want to be able to tell that person is the unique person in my all user base. You can change that, and then it's the quota which we discussed. So if you want to interact with the app from additional backends, then you have to add where they are. You have to add the sort of additional URLs that will work. When you will need to do that? You may want to do that if you have your own backend as well. So you're using Firebase and you're using your mobile app or web app, and you have your own backend as well. That's what we actually have with the EduLab application. We have our own backend, but we are using Firebase for authentication. In which case, I would have in my EduLab, in the signing methods, you will see that I have the additional URL from which I'm making the sort of requests to the Firebase API. So you will have to kind of add that in. All right, so then once you have this set up, you can go back to users and you can sort of add a new user, right? And from the API, you can create new user password users in your app. So you can say, I want some sort of a test user with test.com, and the password is test. And now I have a test user with the email password provider with a particular ID. And I can, if I have my mobile app, I can log in as test.com, put the password, and kind of do the flow, authentication flow with the Firebase backend to get the kind of the authentication done. So if I go to usage, I will see how much I've been using it. And then if you go to if I go, so I can also do email verification. So with email password authentication, I can have email verification kind of added. We will not do that. So what we will do is I will open a new tab. So I will open a new tab and I will go to console and I will go to the docs. And in the docs, I want to start, we're doing for Android. If you're doing it for Unity or if you're doing it for iOS, you will kind of use a different snippets. But if you're doing it for Android, you go to Android, you go to authentication. And you will see there are, okay, let's go back one step. They say, okay, what are the prerequisites? You have to have at least Android 4, and you have to have at least Google Play Services 11.8. You need to have Android Studio, and then there is kind of a quick start. And you have sort of well-organized topics of how you will need to start, right? So with the you can use a pre-built UI, but the pre-built UI works well with the web-based apps and with the browser web view on the mobile, right? So we're not gonna use that. We're gonna start with the normal SDK. So you have to install the SDK into the Android Studio, and then in Android Studio there is, yeah, let me show you. Android Studio. There is a kind of a wizard which allows you to link your project to the Firebase instance. So you've created the Firebase instance using your particular credentials, and then when you want to link it, you basically kind of use the same credentials again. So if I open my chat demo, there is, yeah, once it loads. So in tools, you will have a command called Firebase. You click that, and it sort of does everything that needs to be done to the project, because yeah, I've already sort of authenticated. Kind of already, I have everything kind of enabled, and I can see that for my authentication, I have, yeah, those are kind of tutorials. So this assistant sort of lets you copy and paste code and kind of learn about different modules. But if you, yeah, if you click that on the project that is not linked, yeah, let's try it. Let's create a new project. Chat demo to be deleted. I will not use Kotlin. Yeah, all standard things. So you can link the project to the Firebase, and also the wizard kind of adds necessary components to your Cradle file for building the functionality in. And once this happens, kind of building your project like in the Android Studio is pretty straightforward, because all the dependencies and all the links were kind of taken care for you. What you need to do is you need to check the code snippets that you need for doing the actions that you need to do with the authentication module. And similarly with the search module for the database, search and update. So if I go, yeah, it's still working. So in the meantime, let's have a look here. So you have a couple of functions that you need to kind of support. So one is, how do you do new users, right? We've added new user by hand to our database, and that's one way of doing it, right? For testing, that's fine. You actually don't need to create a new user from the app. It's already there, right? So for an existing users, you can simulate the behavior of existing users by adding a user manually in the console, and then you have the user in there. What you do with the new user? So there is your app started, the user is not logged in, and the user doesn't have an account in the backend. What do you need to do? You need to sort of allow the user to get registered. So one way is you obtain the password and email from the user, and you make this call, right? So you effectively doing, you have kind of an instance of the Firebase, which we will get in a minute, and then you're interacting with the auth module, and then you create a user with email and password, and you pass it email and password, and then you kind of catch if something went wrong, like, you know, there is no network or something. you will get a callback if something goes wrong. So this is a sample on the web, which is not really what we need to show. So we really want to, yeah, so Firebase auth is the instance that we will be interacting with. You're getting a handle on it using simple call, and then they will have similar calls as the JavaScript example that I just showed in a moment ago. So you kind of say similar API. You say create user with email and password. You pass email and password, and then you have add on complete listener, and then you will have a callback which happens when this finishes, right? It's an asynchronous task in the background which will do the creation of the user for you, and then you can sort of see if the task succeeded or if it failed, and you can sort of follow the same logic, right? So one thing is, okay, I have a new user which is not on the backend. I have to get some sort of a flow. I can use email login, so I will need to get email and password from the user and do this call, or I can use the anonymous one, right? So if the user is new and not registered yet, I can do a very simple anonymous authentication, which is very similar to the previous one. It's just that instead of saying create user with email and password, you say sign in anonymously. You don't need anything from the user. It's an empty call, and it also will give you the feedback back. And on success, you basically have a created user, and you can obtain the handle to the user by doing the get current user. Right, so if get current user gives you a user back, you know the user was logged in, and there is kind of a ability for you to interact with the other services of the Firebase. If something went wrong, well, you have to communicate to the user. What can go wrong? Well, you may not have network connectivity, right? So the user started an app, tries to do an anonymous login, and there is no network, so you cannot do that. You need network for that. If you have network, most of the time it should work. There is a limited amount of things that can go wrong here. Could be some problem with proxy or connectivity usually, but if you have a normal internet connectivity, this will succeed. And then once this succeeds, internally, the Firebase instance on your phone already have all the necessary tokens. You don't deal with that manually, right? So it's super simple to have the user authenticated. If you already have the user, like we do with the test user, I can do so those are sort of topics that you will kind of deal when you're dealing with the authentication, and password authentication is this kind of email password one. So I have create user with email and password, and then I have also a call which says sign in with email and password. The difference is that the sign in one requires the user to be already here. The one which says create will only create the user, create a new user, right? So this one will log in the user as well. So the user will be created and logged in automatically. Here you will only allow the user to be logged in. If the user doesn't exist, it will not be created, right? Can you try to create a user again once, like if I have already test.com user, can I call this call and it will kind of succeed? No, it will fail. It will say, well, you're trying to create a user with the same email that already exists, right? It will not log me in. It will just fail. So if you already have a user, you cannot call create user. You have to call sign in with email and password. Okay, is that simple enough? I think it's quite simple. You have the ability to create new user either anonymously or with the email and password. and then you have the ability to log in. With the anonymous one, it's an atomic thing, so you create and log in automatically. With the email and password, you have to decide, okay, are you an existing user? Then you have to sign in. If you never signed in before, you have to create, right? So that's why we have in our flow, with this app that we have login register, and the user has to decide, okay, are you logging in or are you registering, right? I mean, the UI is exactly the same. I have to ask for the email and password, right? I don't need anything else when you're registering. But I mean, because technically all you need for signing in is email and password, and for creating, you also need email and password. You don't create anything extra, right? If you have something extra, you have to deal with that extra in your database somehow, or on the client side. So here, we do the same. When you log in, we ask you for email and password only. But if you say, I want to register, we do a little bit more. We ask you for your full name, email twice, and password twice. And also we do a CAPTCHA to kind of prevent the people logging in, creating an account quickly, upvoting something, and then, doing that. So you have, it slows you down. And we also get kind of a full name, which then shows up here. Instead of your email, we kind of use the full name to do this kind of thing up on the right corner. All right, so now you want to log out the user. How would you find out how to log out the user? Well, you can try. So you can say mauth.logout. Well, the function doesn't exist, right? So the simple way is basically browse the docs and find out what is the function to log you out. So if I say Firebase auth, I will have the a number of methods that it sort of supports. And I have create user, I have delete user, but it kind of doesn't look like that's what we are looking for, right? So let's say so if I say yeah, let's check in the code. In the code, when we successfully logged in, we say get current user, and then we have an instance of Firebase user. So maybe the logout is in Firebase user instead of Firebase auth, right? So if I kind of look for Firebase user, then maybe this one has a logout. It says no, it doesn't have logout. So how would you find it? Well, you can Google for it. Public methods. Okay, so let's try logout. Nope. So let's try sign out. Nope. Oh, come on. So let's go to manage users again. let's see here. So get the current user, get specific information, get user profile, get verification email. We're not doing a verification, changing the password, re-authenticating, delete a user, re-authenticate. Fascinating. So it seems from the Android API, you cannot really log out. So let's see from the web, from the JavaScript API. If I go to manage users, I have a method called sign out. On Android, if I go password authentication, to sign out a user, call sign out. So in the Firebase auth, why we didn't see it in the reference? So viewful API. If we go Firebase auth, there should be a method called sign out. I see. So let's search sign out. Well, so I don't know why the Google Docs don't specify the method, because the method is called sign out, and it's not here. Yeah, I will check it. So anyway, you will where we are? So we know now how to create a user, how to sign the user in, and how to sign the user out. You have to create the UI. Yup. You found it? Where is it? Say it again. Yeah. Fire. I don't know why there are two of those. Third from the bottom. Sign in anonymously. Yes, we see those now. And there is a sign out as well. Yeah, so maybe there are two Firebase auth classes and I was on the wrong one. Yeah, so sign in with email and password and sign out are kind of here. Good. So then how would you sign in with Google? Okay, so with Google sign in, you have a method called, okay, let's not spoil the fun. Let's go to Google sign in. And in Google sign in, they kind of show you, you say, you have to build the Google sign in builder, and then you will sort of run it, right? So you will sort of initiate the Google sign in, and then on activity result, you will get stuff back, right? So it's a kind of a more complicated flow because your app doesn't talk directly to the Firebase anymore. Your app needs to talk to the Google auth provider, signs you in, get the one-time token, talks to the Firebase backend, pass the one-time token. The Firebase backend needs to talk to the Google auth to validate that the token is correct, and then gets the correct answer and handshake back to you saying, everything is fine, the token is not fake, and you've been authenticated, right? So the process is a little bit more complex, and the process is kind of managed by the library for you. And when you get the final fine back to the app, the user will be created on the Firebase automatically. So the Firebase doesn't have a distinction between creating and logging in the user. For the existing user, it will just give you back the current user as the user it used to be. For the new user, it will kind of authenticate you and then check in this database that you have about the users and see, oh yeah, Mariusz is authenticating now, but he's not here with his Gmail account. We will create his Gmail account with the G here, and then we'll pass the token back to the app. So there is much more happening behind the scenes because you're using Oath. And those of you like Tomasz who did deal with Oath, they know how cumbersome that is. You have to kind of manage those handshakes yourself, especially if you have a backend. If you're only doing front end, you're basically saying, okay, Google, can you authenticate this user? And then Google says, yes, the user credentials are fine, and that the user has been logged in. But if you're doing the handshake with the backend, the flow is a little bit different. Then you're saying to Google, Google, can you authenticate me for the backend? Then the Google checks the credentials, checks the permissions, and gives the app back a one-time token, which can be authenticated on the backend. Then you pass that one-time token to your backend, and then your backend talks again to the Google Oath, saying, can you check and validate this one-time token? And then the Google says, yes, the user just logged in, it's a correct user, the token is valid, everything is fine. And then the backend manages the new user or an existing user, right? So with Firebase, you don't need to create new users with Google login or with Facebook login. They will be created automatically every time a new user logs in, right? Is it desirable? It's up to you, right? You can decide how to deal with it. So you can have dual authentication mechanism, which means in the app, you may say there is a list of users which can authenticate using Gmail, but if they don't pass this first step, they will never talk to the Firebase, right? So you may have kind of an additional mechanism for preventing unknown users to create accounts with your backend. If you want to limit like invitations only stuff or whatever that is, right? You may say only existing users can log in with Google, but non-existing users have to have invitation to create a new user. And then you have to manage in a more complicated fashion. The default from Firebase is that everybody with those authentication providers, Oath providers, can be added to your user base, right? And they will be added to the user base. The way you deal with them later is up to you. You can deal with them later. Like you may say, oh, you have been authenticated with Google provider, but you don't have the special thing that I need for you to be able to access my data or whatever that is, right? But the simple things are simple. So if you were to add the Google login, you just follow the Google sign-in thing, which basically creates sort of a Google sign-in activity. Then you kind of start this activity that you've just created. It will sort of do the Android-specific UI and Android-specific flow for the user to log in with Gmail. And then once it's finished, you will have an on-activity result callback to your activity with with the sign-in code, like we've used the code here. So we checked it, and then we have to follow the kind of the Oath with Google flow as an async task again here. And then once all of it is done, and you say get current user, you will get the current user with which has been authenticated with the email with the Gmail credentials. So if you've logged in the user anonymously, and then you follow this flow to log in the user with Google, the anonymous user would be automatically plugged into that Google account. So whatever the anonymous user did, whatever the anonymous user created in your Firebase database will be visible and accessible by the logged in user now with Google credentials. So it's sort of like encapsulated, right? But now, let's say you had a test user with the test at test.com email, and you log in again using the Gmail credentials. Those two are separate. They are not linked. Whatever the test user created is not linked to whatever you've done after logging in with Gmail. But there is this mechanism for linking multiple providers. So if you want for a single user to be able to log in either via email or via Gmail or via Facebook, then you can sort of every time a user is logged in and picks to log in again, you can use the credentials of the current user, current logged in user, to link the other credential authentications with this, right? But you need to have an account which is already logged in. That's what we have when the anonymous user is logging in with the Google. We already have a logged in user. What does it mean to have a logged in user? Well, it means that the call get current user, yeah, let's go back. This call gives you the current logged in user. If this call gives you null, it means the user has not been logged in. There is nobody logged in yet. So this is kind of like you can check if the user is logged in by calling this and checking if it's null or not null. If the user is signed in, you will get not null. If the user is not signed in, you will get null. If you sign in the user anonymously, you will get not null because the user is already logged in. If the user logged in with the email password, you will get not null. So then you can allow, like, let's say I've logged in with email and password, but I still can again log in with Gmail or Facebook. Then you can do this linking. And the linking, well, it's a little bit complicated because you have to do it per case. So you have to create some sort of, yeah, kind of auth credential call for Google or for Facebook or for email, because the anonymous user can upgrade to email-based credentials as well. And then you have to do this sort of flow. Again, it's not rocket science, but it's like it's per case. You cannot kind of have the same code doing the same thing for no matter whether your user picked Google or Facebook. You have to distinguish which one is which. And then you call something which is called link with credential, which they are doing here. So they have the instance of the current user, and they calling link with credential. Oops, sorry. And they calling link with credentials, and they passing this credential thing which they've done either for email, for Facebook, or for Google. You don't need to do the linking. You have to do something simple. So anonymous authentication is fine for playing with it. You don't even need the user password one. But the user password one is sort of good to have, as I said, for testing the flow and testing like the user actually deciding to log in. The anonymous one can be kind of fully automated. You don't even need the button. Like when the user starts your app, you can by default register the user with the anonymous login and don't even give the user the option to click to log in, right? The user by default will be logged in anonymously. And then you can give them an option to log in with Google or something else to upgrade the account. Does it make sense? Okay, so that sort of finalizes the O thing. So let's have a short break, and we will discuss briefly the API for accessing the data, for storing the data and accessing the data. Okay. So let's wrap up. As we were discussing earlier, for the data store, you have two options. You can go with the real-time database or the Firestore. Both are real-time. They both pass the updates, fast, and you can have a real-time app built with the both of the backends. They both offer a free quota, so you can have a free amount of data being passed around without needing to pay anything. Also with Google, it's quite useful because you can set how much budget do you want to spend on a particular app, and you can set it to 0. So then you effectively always in the free quota, even if you have kind of a budgeted particular access, or you can say, okay, 10 cents, and the app will kind of let you go on up to 10 cents, and then it will kind of swap you to a free quota. The free quota has some limitations of how frequent the communication can be and how big the communication can be. But for testing purposes, they are fine. So that's one thing. The second thing was, should you use authentication for the lab 4? Technically, you don't need to, but it's such a bad practice not to have authenticated backend that myself, even for testing purposes, even I'm doing hello world thing, I never enable worldwide access to my backend API because it's so bad. So those of you who want to do it, you can technically do it. We really discourage you doing that, but you could technically do that if you want to. For everybody, we recommend using the anonymous authentication. It's an extra line of code. You have to do this. Yeah, let me see. Let me go here. And if I go authentication again, so if you go anonymous authentication, all you need to do is you have to get the user, and then if the user is not logged in, if you say get current user returns you null, all you do is you say sign in anonymously. And yes, you do need to deal with errors, which may happen when the user is offline, when there is no network, but that's not a big burden. You just show a user some toast or something saying, okay, turn on the network or something. And do this line. Once you do this line, this call will always return you a user, and Firebase will have a user which is passed when you're doing any queries on your database. So then the access to your backend is limited to logged in users. It is much better to open up the access to your backend kind of worldwide, right? So I prefer you doing those two couple of lines of code, the extra line, which is sign in anonymously. You can even shortcut it and assume the user has network, and just don't deal with the error conditions, right? You will have to, like, every time you're doing something with the database, you have to check if the user is logged in then. You have to have some sort of a flag somewhere, because this may fail. I mean, it is not likely to fail on the normal connected phone, but it may fail, so then you have to deal. But this line is very trivial, and then this check you're doing anyway. If you open up the backend to worldwide access, you don't need to do this check because you don't care. But it's kind of, first of all, it's a bad programming practice because you will always care. And second of all, opening up, as I said, the access to the backend is such a bad thing that, yeah, you should never do that. Okay, so let's assume you did authenticate it anonymously. And it sort of allows you to do the authenticated calls to the backend. Then which backend to choose? Real-time database or Cloud Firestore? As I said, it's up to you. I will sort of show you the Cloud Firestore to show how easy it is. I prefer Cloud Firestore because it's mentally a little bit easier to describe how it works. You have this concept of collections and the concept of documents, which is more natural to work with. But those of you who want to use real-time database, that's fine as well. And as I said, this is very well documented. There is a heaps of tutorials on that, and it's fine. It's just that, future-wise, probably this one is a bit more useful, because if you're gonna do something with mobile and Firebase like in 2-3 years, it's probably that one you're gonna be using. So how does it work? Again, you have to have the project, Android project, connected to the Firebase. The same thing as for the authentication. You've already done that, right? So when you've already done that, you will already have the Firebase dependency in your Gradle, in your build Gradle file. And then you just, same as with the authentication, you have to initiate you know, the kind of yeah, kind of like a proxy side of the app that you have to talk to the backend, right? So they're using kind of a concept of kind of a remote procedural calls, and you don't know what's happening behind the scene. So up front, you have sort of the API, which allows you to do the remote stuff with the Firebase. But for you as a programmer, it appears as if it's a local API with some asynchronicity. You have some callbacks and some asynchronous calls. So you need to initiate it, and you initiate it by calling Firebase firestore get instance. If you were to use the real-time database, this is slightly different class. And then you can kind of check how you adding and deleting data or searching for data. So you have, as you see, they don't use JSON, they use a hash map, which is kind of de facto a way of dealing with JSON-like data structures in Java, right? We're dealing with Java, so Java doesn't have, Java is not a dynamic language. Java is sort of a statically typed language. So it's a little bit difficult in Java to say, I have a, where is the, no, the wiping thing here. So for example, in JavaScript, if I have, let's say I have a JSON with name, M, and age 45, right? I can read it into an instance, and I can have an instance O, which is my object, and in JavaScript, I can say, okay, name, what's O.name? It is basically M, right? And I can say O is male equals true, and then if I dump it into the, into my RESTful API, I will have a structure which has those two plus an extra one, which is true, right? So JSON and my objects are kind of the same. In Java, I cannot do that. So how could I kind of deal with the dynamic nature of my JSON structures in Java? Well, I cannot do this. I could do this if I pre-map of what the structure is into some sort of a class. So if I have a class called, say, person, and the class has a field called name and a field called age, and age is integer and this is string, then I can kind of do this. But then if I have O of type P and I want to say O.is male, I cannot, because I don't have that field. But maybe I want to add this field and dump it into a JSON. Then in Java, you cannot do that. So, in Java, we typically use a map, hash map. So a map sort of maps keys into values. And my keys are strings. So I have strings, and my values are arbitrary. Like, it can be a nested structure. I can have additional fields, say, called child, which is, again, of type a person. So it will have its own name, its own age, and its own child fields, right? Or it can be one of the primitive, like a string or number. So maps are kind of a dynamic mechanism, because I can easily do, if I have O, which is my map, I can sort of say get and put, and I can use those keys, which in my case is name or age, to get kind of access back and forth from the object, right? So this kind of allows me to dynamically add properties. So now I can say, oh, put a new property which is male, and set it to true, right? Because I can dynamically do that. So with statically typed languages, there is a little bit of a syntax that you have to deal with. So here you see that I'm kind of creating a new hash map, which maps strings to objects, arbitrary type. And the first two instances are strings. What's the type of this one? So for the last line, what would be the type of the value? Int. Who thinks it's gonna be int? Who thinks it's gonna be something else? What do you think it's gonna be?
I think it's going to be int, but I'm sure because you're asking. Maybe float. No, really.
Close. What is here? Almost anything. Yeah?
The int type that inherits from object into capital I.
Yes, that's right. So we will have Java integer. So there is a class called integer, which inherits from number, which inherits from object. And it is of an object type. The Java type int is a primitive type which cannot be casted to object. It has to be boxed into an object, right? So in this particular case, we passing, in this particular example here, this is an int. This is true. It is an int, but it's gonna be boxed into an integer by coercing it to become an object. So in fact, this line of code is gonna be changed to, so let's quickly do that. So this line of code is gonna be done it's gonna be coerced into this. So this is just a shortcut. Can I zoom it? This zoom with the mouse wheel is so unuseful with the yeah. Anyway, you get the idea that, you know, this is just a syntactic shortcut for really doing that, right? So it's gonna become integer. So those two are strings. This is the integer with capital I. Okay, so we've created kind of an user instance, which is our hash map, which is basically a map of keys to values. And then we have a reference to the collection, to our database, and we can isolate the collection out of it and kind of add this new user. And again, we have, you know, on success listener, and it has kind of methods which you can handle success or failure of that particular call. So when I say add user, you know, things may happen correctly. Asynchronously, this user will be added to the backend, and all the handshake will happen, and it will be correct. In which case, I have on success listener. So what to do when the code succeeded, and then I have you know, failure listener. What to do if the code kind of failed. Similar for reading data. I can get all the users from the collection, so I can say .get, and then again I'm doing something with the users when I got it. So what you need is kind of adding new data, reading the data, and deleting the data, right? So when you want to delete, you basically have a concrete document with the key that you call delete on. And again, you have on failure and on success. You can delete individual fields. So you can create, so here we kind of created a new instance of an updates, and we said this key has a value of type field value delete. This will kind of set the value of that key in such a way that when you call an update on the document reference, that field is going to be deleted from the database, right? What is the alternative? The alternative is you can fetch a document, remove a particular field from it, and then update the document. But you know, it will update the fields that you've changed, but it will not delete the field that you're missing. So the update will kind of check all the fields that you have in your update document, and it will kind of update them in the database. But then the ones that you're missing will be kind of ignored. It's a little bit different with Mongo, because in MongoDB, if I kind of set a particular field to undefined and then push the document back into the database, it will actually store the new document entirely, right? It will not, so when I call save, it will sort of modify the fields that I'm missing in the original document. You can delete the collections and so on. So you have sort of the default things set up here for dealing with the access to the database. So the last thing I will tell you today is it's a little bit tricky to work with the Firebase remotely, right? You're developing on your laptop and you have to log in with the Firebase remotely, and you have to test your stuff remotely with the database, right? And usually what happens is you have kind of your deployment running on Firebase, and you want your tests to be kind of running locally or tests running on a different database. You don't want to be messing up with the real deployed system. So you're kind of trying some things out, and boom, you deleted your collection, or you've done something that is irreversible, right? You don't want that. So with the Firebase, you have the ability to set up your own local Firebase instance, and it will talk, instead of talking to the Google one, it will talk to your local one. And the local one will have its own local authentication and local database. It is a little bit work, okay? So for lab 4 or for the project, if you don't want to do that, you don't have to do that. If you want to do it properly, you should set yourself up to have this local Firebase instance running. How complicated it is? It is not that complicated, but it is an extra work. So you have to install kind of a command line tools for Firebase on your local machine. And once you do that, you have to launch the local instance of the Firebase. You have to set up your local users, as we've been doing with the console. And you have to point your app, instead of using the global one, the Google one, your local one. The advantage is you have a clear isolation of the local environment and the production environment, which is desirable. You have ability to work without the network access. So you can kind of work offline and test your stuff locally on your laptop, because you don't need to talk to Google. Unless you're using like Google Auth, then you have to have your network connectivity to test the Auth flow. But for accessing the data and using kind of a local email password or anonymous logins, you can do all those tests like locally on your local deployment. So I do encourage you to do that. It's not strictly necessary to do that for the labs of even for the project. It may save you some headaches, and it may save you some problems, but you need to do that. So you can go. There is a little bit of a tutorial of how to do that. So let me just check. So it's called, yeah, so you have, you have kind of a big topic called testing functions, and then you can set things up in kind of a cloud functions shell. So you enable certain modules which are normally hosted in Firebase to be kind of pretended on your local deployment. And then you can set up like authentication module and your cloud Firestore module to kind of be run locally. You can pick what you want to run locally. And in that case, you will kind of end up with your Firebase command line interface. And the Firebase command line interface has a command called Firebase, same as we had with Heroku or Google App Engine, which kind of allows you to interact with the remote one and with the local one. The good thing about the local command line interface, you can sort of set new users or change things and browse things like from your command line on the Google one as well. And I've used it, for example, to add users or to migrate some users from my legacy system to Firebase. You have to use the command line interface to do that. You cannot do that with the GUI. And then you will have a command called Firebase serve. And it sort of basically fires up a local copy of Firebase and exposes some of the functions. And then you will kind of, interact with that one. So if you create a user, it will be kind of stored locally and it will persist. So that's pretty much it. Your command line interface will allow you to interact with the Google one, and that's why you have to set up these admin credentials. You don't have to do that for testing. So you can only use the local Firebase for your local tests without this having an access to your production server on Google to kind of manipulate the data. But if you want the local one to have this access, or if you want your backend to have access to the Firebase as well with admin privileges, for example, for creating new users, then you have to set up these admin credentials. Again, it's not super hard. You basically will get like a API key and API kind of a secret, and you have to initiate the access to Firebase with this API key and API secret. And then suddenly your Firebase kind of procedural calls will have the admin privileges, and you can create new users and you can do certain things that the normal API don't allow you to do. But you don't need that for testing, right? You can do most of the things that you have to do as an admin using the Google console, the Firebase console. That's what we've been using here. You can interact with the database, set up the authentication, and so on. You can kind of do that with the UI. You don't need command line interface to do that, and only use the local deployment for local testing. Is it understandable? Right, so if you have any problems, fire up some questions on issue tracker, and we will try to address it. The documentation is pretty decent. You can find most of the things, easier or a little bit harder on the Firebase docs. They provide you very clear code snippets. Reuse it. You don't have to, credit it. It's just the way you use the API. If you have some API problems, then let us know. And conceptually, I think you get a kind of understanding of what is where and what you use what for. So that's it for today. Any questions? Okay, thank you. So I remind you that tomorrow, the first part of the lecture will be kind of a discussion on feedback for the course. So if you have any, bring it on. Tell your friends to ask your questions, so it's anonymous. Think whether we are pushing back the deadlines for the labs or not, so you can have a discussion and we can kind of have a vote tomorrow in the class. Okay, thank you.
I'm sorry, but I cannot find anything anywhere on actually returning anything.